Hi, I'm Dimitris Charalambidis, and in this presentation we learn how to solve equations by working backwards. One way of solving an equation is by working backwards. The working backward method can be described by the following steps. In step 1, we begin by translating in words the given equation, starting by the variable and then making new substeps in which we describe any new operation made. For example, in the equation 3x plus 5 equals 11, we can create the following substeps. At first, we start, as we mentioned, from the variable x. Then, the second substep would be that we have to multiply by 3. Then, as we can see from the equation, we add 5. And finally, all this results to 11. Let's do one more example. Let the equation 2x plus 4 divided by 5 equals 4. This equation can be described by the following substeps. As we mentioned, we always begin by the variable x. Then, as we can see from the given equation, we have to multiply by 2. Then we have to add 4, then divide by 5, and finally result to number 4. In the second step now, we are ready to move or work backwards. To do that, we use the substeps we created in step 1. Using these substeps, we begin with the result, which is actually the final substep, and we alter the operations as we move backwards or upwards, if you like, until we reach the variable, which is the first substep. By altering operations, we mean that if in a substep there was addition, now it will become subtraction. If in a substep there was subtraction, now it will become addition. If in a substep there was multiplication, now it will become division. If in a substep there was division, now it will become multiplication. Once we reach variable, we stop. The value of the variable is the solution in our equation. Let's now see some full examples. Solve the equation 3x plus 5 equals 11 by using the working backward method. In first step, as we mentioned, we must create the substeps. We always begin with the variable x. Then, in our case, we multiply by 3. Then we add 5. And finally, we end up with the result, which will be number 11. In the second step, we must alter the operations described by substeps in step 1, starting by result. So we begin with the result, with number 11. Since we had to add number 5, this time we'll subtract number 5. So we have 11 minus 5 equals 6. Moving on, since we had to multiply by 3, now we'll divide by 3. So we'll have 6 divided by 3 equals 2. Finally, this is the variable. So we have x equals 2. This means that the solution in the equation is number 2. Indeed, we can check that 2 results in a true statement. For example, if we place number 2 in place of x and do the operations, we'll get that 3 times 2 plus 5 equals 11. Thus, 6 plus 5 equals 11. Thus, 11 equals 11, which is a true statement, and this means that indeed number 2 is the solution. Solve by using the working backward method the equation 2x plus 4 divided by 5 equals 4. Once again, in first step, we'll begin by creating the substeps. As always, we begin with the variable x. Then, in our case, we must multiply by 2, then add 4, then divide by 5, and finally end up with the result, which is number 4. So, now, in second step, we'll do the backward part. We'll begin with the result with number 4. Since we had to divide by 5, now we'll multiply by 5. So we'll get that 4 times 5 equals 20. Since we had to add 4, Now we'll subtract 4. So we'll get 20 minus 4 equals 16. Since we had to multiply by 2, now we'll divide by 2. So we'll get 16 divided by 2 equals 8. And this will be the value of the variable. Thus, x equals 8, and this means that the solution of the given equation is number 8. For any questions about this presentation, you can leave comments down below, or you can contact me with one of the following ways, either on my email or in my Facebook page. As always, thank you for your time.